In this video we discover the scalar product. The scalar product is a very important tool in mathematics and has a huge practical impact. In the next video actually, we will dive even deeper into the meaning of this tool. Welcome, I'm Alex. Let's cook some math. The scalar product requires two vectors. In our example, it is vector A and vector B attached to our origin. Both vectors are related by an angle phi, which describes how far they are apart from each other. The scalar product comes in two versions. One is the polar identity, which relates the vectors directly to the angle. The other is the Cartesian identity. It performs a very simple multiply-add operation on the components of the vectors. Together, these equations can be used to figure out a lot of useful properties. Note that the result of this operation is in both cases a scalar value. In our videos, we use the academic version of the scalar product using the transpose of a vector by definition. The version you hear in school is called the dot product, and it displays the vector names side by side with a dot between them. We exclusively use ATB. Multiplying a vector like that requires a row vector, so the transpose is the correct way to write it. Usually, you do not have the angle between the two vectors. In game development, you most likely work with Cartesian coordinates where no angle is directly involved. Cartesian coordinates are very useful for displaying purposes, so you will be handling the Cartesian identity most of the time. If you want to know the angle between the two vectors, the polar identity is used. And rearranging the formulas leads to a cosine identity, which allows you to figure out the angle between the two vectors. Note that this formula divides by the length of A and B multiplied. We can safely say that the cosine of phi is the scalar product between the unit vectors of A and B. Let us look at two interesting examples involving the scalar product. Most interestingly is the fact that if the angle between the vectors is exactly 90 degrees, the vectors are said to be orthogonal or perpendicular to each other. In this case, the scalar product equals 0 due to the disappearance of the cosine, which will become null. If the angle between the vectors is 0, both vectors are pointing in the same direction and we call them collinear. The cosine becomes 1, but what happens if the angle is 180 degrees? Please test it out. Let us look at another very interesting property of the scalar product. It is the orthogonal projection that is performed on one of the vectors. This is done by normalizing the vector that will be the one projected on. The equations reveal that if vector b, for example, is normalized, its length will become 1, so only the length of vector a will remain. The value domain of the cosine is -1 to 1, so the vector a's projection varies from minus to plus its length. The cool thing about it is that you don't need the angle for performing this operation. You can simply use the Cartesian identity. Let's close this video with some examples. In this video we learned about the scalar product. It will become very clear in the next video what we can do with it and how important it is for our goal of mastering math for coding or game development. I hope you liked it. Please like, share, subscribe and comment. Bye now!